Number 10. Sally travels by car from one city to another. She drives 30 minutes at 80 kilometers an hour, 12 minutes at 105 kilometers per hour, 45 minutes at 40 kilometers per hour, and then she spends 15 minutes eating lunch and buying gas. Determine the average speed for the whole trip. Determine the entire distance. What I would end up doing here, the time intervals are not even, so you can't just average them. Plus, she stops for part of it. What you really need to do is take each interval, so there are 4 different sections, the half hour, the 12 minute, the 45 minute, and the 15 minute. Take those sections and figure out the time, or not the time, you got the time there. Figure out the distance gone in each part of it. Add up all those distances, all 4 of them, one of them being 0, and then use the total time converted to hours, and then find the average speed. Of course, then you do part B before part A there, but you'll still get all the answers. For number 12. What would the acceleration of a turtle be moving? It has a constant velocity of 0.25 meters per second to the right. Well, if its velocity is constant, it's not really accelerating, so the acceleration would be 0. 13, they want you to draw some graphs, and with these graphs, let's say you got your graph region right here. Okay, you got your graph region, and they're asking you to draw lines on these graphs. And first of all, consider 0 to be maybe in the middle. There's your 0 mark, that one. For each one of these things, they're going to be asking you things about velocity versus time. So you got to think velocity. If your velocity, you have to ask yourself, is my velocity going away from 0 in the positive direction? Is it going away from 0 in the negative direction? Is it going towards 0 in the negative direction? Or towards 0 in the positive direction, or is it maybe just going straight somewhere? You know, those are the kind of things you need to think about, and I wouldn't be upset at all if you put maybe all 5 on one graph, kind of like I did there, and then you can kind of see the differences between them as you do that. Number 14. A car is traveling east. Can its acceleration be to the west? Yes. If you consider east to be positive, west would indeed be negative. You can certainly be traveling in the positive direction and have a negative acceleration. That's called slowing down while going whichever direction. Then let's see, we have 16. A car is traveling in a straight line, has a velocity of 5 meters per second. It accelerates by 0.75 meters per square second. The car's velocity is then 8. What is the time? You are going to use the plain old average acceleration equation right here to answer that. You've got your change in velocity, you've got your acceleration, you've got time. And then number 17, on the graph below, so you got another graph there. Find the average acceleration for the time intervals. Well, I'll tell you, from 0 to 5 seconds, your acceleration is flat, so 0, and from 15 to 20, oh, they're not asking 15 to 20. They're asking them 5 to 15, so you'd have to take the 2 points along that line and find the slope of it, or find the change in velocity that the line represents there, and the change in time. You can consider the top and bottom to be the nearest whole number, because I'm not going to give you a graph where you're not going to be able to figure out the values. And then for 0 to 20, well, then you just take the grand total over the whole time. For, I believe, back here, and let's do 18 last. A bus slows down uniformly from 75 kilometers per hour to 0 kilometers per hour in 21 seconds. How far is it travel during that time before stopping? So we're looking for distance. They give you time, they give you VI, they give you VF. So if we go back to this page here, this one right here, they give us time, so time. They give us VI, they give us VF, and they want to know distance, so not acceleration, therefore this one here, time, VF, and distance. Use the meters per second, because they give you time in seconds, and you'll be able to calculate how far.